There is a very strict definition for showing that a function is continuous at an x value. You must show these three steps. The function is defined at that x value, the limit as x approaches this value exists, and the function value is equal to the limit as x approaches this value. So here they've given us the function that is a piecewise function, g of x, and they want us to see, is g continuous at x equals 3? So I'm going to check these three steps. First, g of negative 3 is going to equal f of negative 3, which is square root of 25 minus 9, which is square root of 16, which is 4. So that was step 1. The function is defined at negative 3. Step 2, we need to check that the limit exists. So the limit as x approaches negative 3 from the left of g of x is going to be square root of 25 minus 9, which is 4. Then we have to check the limit as x approaches negative 3 from the right of g of x, and that's going to be negative 3 plus 7, which is 4. So therefore, that implies that the limit as x approaches negative 3 of g of x is 4. So the limit exists. That's step 2. So then lastly, step 3, the limit as x approaches negative 3 of g of x equals g of negative 3, which equals 4. We check that. Therefore, g of x is continuous at x equals negative 3. And yes, you must check these three statements before you can make this conclusion.